Welcome back, guys. Lesson 4. This is called Reasoning in Algebra. This lesson is an introduction to proofs. Now, proofs are just mathematical arguments, which sounds really exciting, I know. And they lay out step by step how you get from like the start of the problem to the answer. A lot of times that's like the hypothesis to the conclusion, which that ties this in nicely to what we're learning this unit, because we've done a lot with conditional statements. Now, proofs are typically shown, and there's different ways of like organizing the information in your argument. In this class, we stick with what's called two-column proofs. But there's other ways to organize your information. There's something called a flow proof. I'll show you these a little bit in Unit 4. There's even paragraph proofs, which is gross, and it is what it sounds like. You just write out your math argument, how you solved the problem, in a paragraph. Gross. I'll show you, but we won't write those. Now, each step in your proof, you have to justify. So each step must be justified or explained. The justifications that you use, a lot of time it's just like a definition, a postulate, which remember that's just something we accept to be true. There's something called a theorem, which we'll get to, or other properties. So you're just explaining like why you did what you did or how you know that that works. That's why you must know these 9 little properties here. Now, all but 3 of them are algebra. So kind of makes easing into this proof stuff nice because we know a lot of algebra. We passed that class last year. The first 4 properties here are pretty self-explanatory. And they all start with like, if something equals something else. We generalize it, that's what we do in math with letters. So the addition property says, hey, if 2 things are equal, and I just wrote the exact same thing, if A equals B. The addition property says, if 2 things are equal, you could add something, the same thing, to both sides of your equation, and it would still be a true statement. They would still be equal. Sorry for all the letters. And really, all 4 of those properties start off that way. If 2 things are equal, the subtraction property says you can subtract some number from both sides, and it's still an equal statement. Multiplication just means you can multiply the same thing, and division, you can divide the same thing on both sides, and it's still true. Notice you can't divide by 0. That is not a thing. Now, substitution and distributive property, you know those words too. So maybe let's look down there next. And it starts the same, if A equals B for substitution. If 2 things are equal, basically like those 2 things, A and B, can replace each other in any expression. And then distributing, hopefully, and if there were numbers there, it would make more sense. But if you've got something sitting outside parentheses, you can just distribute it. So that would like look like that. I know the letters make it feel like a foreign language. Sorry. The 3 that I highlighted, again, these are the only 3 that are new properties for today. And you might have to memorize them, but we'll cover them pretty well in class, so hopefully they'll kind of like hit home eventually. But the reflexive property, and we do this a lot with proofs, it just says that something equals itself, which I know is even silly to write, but it will come in handy. And I just remember that because I think of my reflection. If I'm looking in the mirror, it's like me and me. It's the same on both sides. The symmetric property just says, and they used congruent, which means equal, but if A is congruent to B, you can flip that around and put B first and A second, and it still means the same thing. And I just think of like symmetry here. Symmetric property, symmetry. If something's symmetrical, it's like the same on both sides, so you could flip it and it would look the same. And then the transitive property, and I know this is kind of going fast, sorry, but transitive, I think of the word transition to help me here. Whoa, transition, sloppy. This is a little bit longer, but it says, if A is congruent to B and B is congruent to C, then what can you conclude? If the middle part is the same, B and B, you could just jump from the beginning to end. And I could conclude that A was congruent to C. It's a transition. All right, there's all the info. Let's practice this stuff. So in the first 4 problems here, they just want me to name the property that they're talking about from this list up here. So number 1 says if x plus 4 equals 9, then x has to be 5. And I think that we would agree with that statement. X would have to be 5. Well, now I need to justify that argument. How did I know that x would be 5? Or in other words, how would I solve this algebra problem? You guys all know you would subtract 4 from both sides. That's just called the subtraction property. You subtract something from both sides, subtraction property. Number 2 says if m equals 2n minus 5 and m plus n equals 16, then what can I conclude? And they're telling me think substitution. So substitution is just replacing for something else. M is the same thing as 2n minus 5. So I could come to this second equation, and instead of writing m, I could replace it with 2n minus 5. So it would look like that. This was about a year ago that you did like systems with this stuff. Of course, I'd want to combine those n's, combine some like terms, and make it look a little bit nicer, but that's what I could conclude from the substitution property there. Wouldn't go any further, don't really need to, they just wanted me to substitute. Number 3, and they're telling me use the transitive property, so that's this transition thing. If P is the same as Q, and Q is the same as R, remember we said if the middle is the same, you can jump from the beginning to the end, and you can conclude that P is the same as, not R, losing it, or not Q, really losing it. P is the same as R, sorry. I need a nap. Okay, number 4, I'm going to have you guys try that one. And then I'm going to do example 1. So here's where we're really taking our algebra skills, and I'm not asking you to solve the algebra problem here, like not at all. And I even noted that at the bottom. I'm not checking to see if you can solve an equation. I'm checking to see, can you justify the steps? Can you like explain how you got what you got? So here's the algebra equation that's being solved, and you see the answer is 11. So I don't have to solve it, I just have to justify the steps. And guys, this is a 2-column proof. They've got like the algebra work on one side, the math, and then on the other side, they have, and this is where we'll write our explanations, how we solved it. So here's what you have to do. You look at the problem. The first thing they did in solving for x is they went from this line of work to this line of work. So whatever they did to go from this to this, you're going to explain that on line 1 here. So you gotta look. I noticed that it's no longer 5x to lead, it's 4x. So they did something with the x's. They subtracted this x over. And if you subtract something from both sides, that's just the subtraction property. So that's what I would write on line 1. Don't overcomplicate it. Same thing. What did they do to go from line 1 to line 2? Because that's what I'm going to explain on line 2 here off to the right. So the 12 is gone, and most of us, if we just solved this algebra problem, that's exactly what we would do next. You'd add 12 to both sides. If you add something to both sides, that's just called the addition property. And in the last step, they divided by 4 on both sides to get an answer of 11. So you just end with division property. That's it. Okay, so the math really isn't the new part, like actually solving. It's practicing, like justifying the steps. That's what's new today, and I know that's weird. Here's a geometry problem. This is something we did last unit. It's kind of set up weird here, but they give you like a given and a prove. And the given's like the hypothesis, and the prove is like the conclusion, the answer. So in other words, they're just saying like, if you know that the measure of angle ABD is 107, then I could conclude and figure out that angle ABC is 66. So it's like me asking you last lesson, hey, if you know this whole thing is 107, that's ABD, how big is this angle ABC? How big is this piece? You had problems exactly like that on your Unit 1 test. So solving the problem shouldn't be the hard part. It's like justifying off to the right. Watch. And proofs are really specific. They're really detailed. They're like over the top detailed. It's like super unnecessary and extra. But I mean, if you're in court and you're a lawyer and trying to like argue that someone killed someone else, which is a lot more exciting than a proof in math, you would go over the top and be like extra with your explanations. So here's how this proof would start. And you don't have to come up with the outline of the proof. You just have to fill in all of the lines. So don't panic. But they say, okay, ABC plus CBD equals the whole thing. If you add two pieces together, it equals the whole thing. This was called the angle addition postulate. We learned this last unit. Yay, don't you love when things come back to haunt us? Only two things come back to haunt us, don't worry. So if you add two pieces together, it equals the whole thing. Angle addition postulate. Now they're telling me, and off to the left here, this is like the math. Off to the right, this is the justification. So they're telling me to go from here to here, they did the substitution property. So basically, instead of writing ABC, they wrote what ABC equaled, 4x plus 2. And then CBD, they wrote 3x minus 7, and ABD, I know ABD, it was 107. They gave me that. So they just substituted for those angles what the angle was labeled. Okay, now they are starting to do the algebra. So this starts to make a little bit more sense, hopefully. Let's see, they went from this to this, so I got to justify what they did on line 3. And I see 7x is now there. So it looks like they put the x's together and they put the numbers together. Now, this can be confusing. This is not called the addition property or the subtraction property. They didn't add something to both sides of the equal sign. They just like combined like terms on one side. If you combine like terms, you just put simplify. Or you could put combine like terms, but it's not the addition or subtraction property. They didn't do something to both sides. Be careful. Now from here, you just got to think, what would I do to solve this algebra problem? Well, hopefully you would add 5, and you'd have 7x equals 112, and you added to both sides. So you just say the addition property. Then you would divide by 7. Hopefully that's what you would do, and x would equal 16. You don't have to show the steps. I just did on here for the sake of learning. I divided. I justified that answer by saying the division property. Okay, they're going to keep going here because the proof was like what we were trying to get to. We were trying to show that ABC equals 66. So let's see what they did next. Well, they said, okay, the measure of angle ABC equals 4 times 16 plus 2. They went up here. Here's ABC. They just plugged in 16 for x. So think, if you replace something with something else, that's called the substitution property. And I know this is not easy. If you're like struggling, don't worry. You're not supposed to be an expert after watching 15 minutes. And then they just kind of said like what the answer was. So they just like worked out in their calculator that equaled 66. So that's just kind of like simplifying. You just worked out what something like equaled on one side. Okay, that's done. Now, notice how the last step right here, that is what we were trying to prove up here. That will always be the case. When we do proofs in Unit 4, what we're trying to prove, and it'll say like, you're given this, prove this, write an argument. What we're trying to prove will always be the last thing on like our 2-column proof. Whew. Okay, last example. Suppose that A, B, and C are collinear on the same line, and B is between A and C. So they're all on the same line. B is between A and C. I don't know if it's at the midpoint. I just know it's between. Okay, picture's going to help here. AB is 2x plus 4. BC is 15 minus x. And then I know that AC, the whole thing, is 21. I want to show that x equals 2. The math is not necessarily what's being tested here. Again, we're writing out the justifications. So, to start, I would do the segment addition postulate. And they're going to be super extra again, and they're going to use letters probably to start. If you do this piece plus this piece, it should equal the whole thing. Then instead of writing AB, they put 2x plus 4. And so on and so forth. That's called substitution. Okay, I'm going to run out of time, so I'll finish the rest of this in class when I see you next.